All right, I'm Joe DeVivo. I'm an Erlanger at Basho, and I'm here to talk to you about Cuttlefish and easing the pain of Erlang application configuration. So if you've got an Erlang application, you probably know, you probably configure it with appconfig, sysconfig, vmargs. You know, -config comes for free with Erlang, and that's all easy, so we use that. And great, you're writing an application because you want to solve some problem, and configuration isn't it. So use these guys, and you get to the real work you want to get to. That's what happened with React. What we got here is this is the React config I used to deploy my first React app. This is 0.10.2, and what we're looking at here is about 10 to 12 lines of configuration that you actually need to change. So great, there are a couple inline comments here tell you what to do. So great, you turn your knobs, and good, we got to get on to writing databases anyway. Well, almost, because here we got the vmargs file. You may or may not be familiar with it, but I guess most of you are, because you've got to configure this name thing. That's not something you can skip. So yeah, we got to touch two files. We got two different syntaxes here, and that's great because why? Because you know what kind of file you're editing, and I don't know, it's not that great. But it's fine because, I mean, it's small font, but you can see this is really all you had to deal with. You change these couple of things, you look at all the configuration files, you close them, it's write once and forget. So we're moving on. And we don't really have time to deal with config files anyway. I mean, our job is to add features and make React more robust, and these files take care of themselves. Plus, OTP says to do it that way. And I don't want to make this little guy angry. So great, that's one less thing for us to decide. We'll just go back to writing database. So the problem with this approach is that configuration is a part of your application's user experience, and it deserves a little bit more than that bit OTP gives you for free. I'm hyperbolizing a bit here, but take React API, for example. We've got HTTP interface, we've got a protocol buffer interface, we've got client libraries, but what are we really doing? We're really writing keys and values to a data store. So why do we need all this syntactic sugar when RPC call will work just fine from any Erlang VM? Yeah, well, it's not enough because we don't want to have to force users of React to use the Erlang VM. And even more generally, you shouldn't have to know Erlang to use React. So why do we feel it's okay for you to have to know Erlang to configure React? Well, it's easy. It's not. So welcome to React 2.0. We completely changed how you configure React for a 2.0 release. What we've done is we've taken the appconfig, we've taken the vmargs, we've added a little love, and we've taken out a bit of the complexity. And what I'm giving you today is React Conf. What do you know about React Conf just from looking at this one slide? There's only one file. That's it, just one to look at. It only has one syntax. I shouldn't even have to say this, but the fact of the matter is that we had two syntaxes before, and so it's great. Now there's one. Everything you need to know about a single configuration setting is on a single line in this file, which is great because you can actually use command line fun like grep and stuff like that to actually find out what a thing is set to. And with an Erlang app config, you actually, it's a prop list of prop lists, so you have to have context for where the setting is before you actually take a look at it. So this is good. It's it's very clear. It's very simple. Another thing I really like about this is that line can be anywhere in the file. Because you don't have to be aware of what module you're configuring, what library you're configuring. You don't have to be worried about like list syntax. That line doesn't change if it's in a different place. You don't have to worry about trailing commas or like anything like, oh my God, I set this thing and then commented it out, and I'll show you an example later. But it's just little things where you want to change one thing, you should only have to change one line. And so I got thinking key value is a pretty good idea. Started to remind me a lot of syscuttle. Less about any because any still has that concept of groups, which doesn't give us that whole everything on one line thing. And it looks like this. Now, what we're looking at here is a lot of comments, because comments are still important. Documentation of your configuration, what people are doing. When you open up this default config file for React, what you end up with is settings that you understand what they're doing because they kind of tell you. So on this slide, we've got two actual settings in all this comments. So these two down here, and it's just key equals value. If you set something more than once, the last one wins. This means you can append to a configuration file and affect change. It's great for testing. It's great for developer testing. It's great for automated configuration and deployment tools. There's built-in documentation in the configuration. You can use this command react config describe and then talk about a config setting. It's going to give you documentation. It's going to give you the data type. What's that? You don't know yet. Default values, what you've set it to if it's different. Even if it's the same, it will tell you you're still using the default. And then this little line down here, this one little callback to our days of yore with Erlang app configs. You know, this used to be that. And if you're an Erlang developer, that may still be important to you. And we'll tell you about that. So yeah, configuration values have data types. We can actually specify something like the search solar start timeout is a duration in seconds. And you can specify the default value is 30 seconds, but we've set it to 45. You can set that in minutes, hours, days, weeks, fortnights, but nothing bigger than that because everything else is, you know, variable time durations. Try and tell me how many milliseconds is in a year. It's obnoxious. But I don't want users doing math about milliseconds. Now they don't have to. So this is a little artifact of what's happening here, and I'll get to that. Remind me. Don't remind me. I'll remind myself. So configuration values can be validated. What that means is, you know, we're actually reading in these values and not only saying like, you know, is this a valid term in Erlang? You know, we're saying, is this a thing that we've accepted for this value? And you know, we'll get to that more in a little bit too. But when you validate in config, if there's an error in the configuration, you'll get a decent explanation. You know, log messages for humans. It's not a dream. It's here. Take a look at unknown key. This is when you try and set something that you shouldn't be able to set. You know, anti-entropy, we've got active and passive anti-entropy in React. You can choose between them. I wanted to choose passive, but I spelt it wrong. I typed anti-entropy because I thought I would win a trophy today and had that on the brain. So what happens? Well, I try and start React, and it tells me, no, you can't, because there's no setting called anti-entropy. Did you mean one of these? And it does some Levenstein string math and tells me, oh, yeah, these are the three things that are closest to that error, and that's it. So now I know, yeah, that didn't do what I wanted. I'll only go back and fix it. Same thing works for value. We have complex validators for value. And what we can say here is that the ring size for React must be a power of 2. 42 is not a power of 2. So I tried to start it up, and it complained about it. So what happens after it complains? Well, if there's an error in the configuration, React won't start. And we talked about whether or not to actually do this, and we landed on doing it because what happens if you're in the situation where you try to configure a React node to do something, and then you think that you've succeeded, but you actually haven't because you fat-fingered anti-entropy before? Well, you start up your node, you think it's doing something else. That's an inconsistent user experience to me. And so what I want to do is on start time just tell you, hey, your impression about what this node is about to do is incorrect. You can view the effective configuration of a React node. You can say at any time, I mean, there are a lot of default values that are set, and everything should have an explicit default, and I'll get to that in a little bit, but when you don't set something, there's still a value that's usually associated with it. Sometimes people like under the hood are using like the application module, and you use getEnv3, and that's how the default is set. I don't like having people having to dig through code to find out what the defaults are, so Cuttlefish provides a default syntax, and we'll get to that. But anti-entropy active is the only thing that's actually in the conf file. All these other anti-entropy settings are things that are defaults, but you can see them with the effective config. Yeah, I got the idea from Maven. It's not all bad. So yeah, there is a definitive place to look for default configuration settings. For humans, it's that documentation describe command that I was talking about before. For programmers, it's something else that we'll talk about in a little bit. But most importantly, there's no Erlang required. We haven't talked about any Erlang yet. Nobody's done any Erlang to configure this React node, and I think that's really important. And why is, I'll tell you later. But as far as React 2.0 goes, you can upgrade from React 2.0, from React 1.4, and you can use your app config and VMRs as they exist. Cuttlefish is smart enough to say, oh, you've got an app config and VMRs already? Just use those. And you can migrate your settings to React Conf at your convenience, and when you delete app config and VMRs, it will just start using those. Now, caveat there is sometimes, like in a big release like 2.0, we introduce new settings. And when we introduce new settings, obviously there are no defaults in 1.4 for settings that have been introduced in 2.0. So we'll actually just use the defaults, not from Cuttlefish, but from the application. So just, use React Conf, it's better. You can do cool command line foo with config files that work like this. You can, cat, I don't know if you guys can read that, but I'm catting the conf file and searching for lines that start with anti-entropy. But then I could also cat the effective config file and see all the lines with anti-entropy and see all the different settings that are actually in place here. And then my favorite, this example here where I look at the effective config for the anti-entropy concurrency limit, it's 2. I want to echo anti-entropy concurrency limit equals 4 into React conf. Well, now the effective config says it's 4. So this is just the last right wins thing again, but I think it's cool. So there it is on my slide. So what is Cuttlefish? Cuttlefish is this configuration tooling. It's available for everyone, for every Erlang app. You can use this. It's not just for React. And if you want to use it, I'm going to try and convince you now you should. It's pretty easy. So Cuttlefish is an Erlang library for human-readable configuration files. It's a pun on sysctl and Babelfish. Not Battlefish, that's ridiculous. So why use it? Well, if you don't know Erlang, you probably don't like the syntax. The Erlang syntax debate rages on. It's terrible, but the bottom line is it isn't a great syntax for configuring things. And it's not that it's a bad syntax, I like it. But configuration files are your application's first impression on the user. And what Erlang configuration files are going to do is tell a user, your application is harder than they think. It's not hard to configure things, especially when you're writing Erlang config files and you know Erlang. It's easy for you guys to configure these things, but it's not easy for them and they get scared. You don't want to spook them. You are not your application's average user. If you've written this Erlang application we're talking about and you have users in mind, you're probably no longer qualified to answer the question, would my user mind an Erlang config file? I mean, you've written an Erlang app at this point, so you've fallen in love with the syntax and it makes perfect sense to you, and you can't put on your outsider hat anymore. It's fine. I've done it myself. If your user doesn't know about your app config, your ops team is your user. So, make life easy on them too. It's, Basho, we ship React to customers and they deploy it, so we have to worry about what our config file looks like. But if you don't, somebody's deploying it. Maybe they sit at the next desk to you, but be nice to them. So, Cuttlefish generates all the app configs and VM args that growing Erlang VMs love. What this means to you as a developer of Erlang applications is that you can still use the application set get env functions to pull configuration out of this thing. You use this syntax that's easy for humans, and then it converts it to a syntax that's easy for Erlang. Bad configuration should fail fast. With an Erlang app config and the application module, some of these settings don't actually get read until when a service is starting or at some point, not necessarily start time. And if you have some sort of invalid config value that's a valid Erlang term, but maybe you're expecting an integer or something like that, it's not something that that may be obvious right away at start time. So when we're talking about let it crash a lot here today, but I'm talking about don't even let it start. If there's a problem, tell people and let them get it right from the beginning. A validated configuration is an easy way to prevent early user errors. People that are starting to use your product and they get tripped up early in the configuration. You might be handling support tickets for them. You might be handling developer resources on these problems that should be something that we can programmatically explain to people. So simple configuration errors can be avoided and avoid a bad first taste in the mouth for this application. Product upgrades can be smoother. When people upgrade from React open source to React EE, there are a couple extra config settings in the app config that they need to add. The boilerplate config, if you don't add it, your node won't start, and it'll be kind of cryptic as to why, because it's Erlang, so it wouldn't be Erlang if we weren't cryptic as to why something happened. But yeah, this with the explicit defaults that Cuttlefish provides, if you switch from React to React EE and use the same conf file, any explicit settings in any EE modules that you might need are going to be provided by default. So same conf file works for both. It's not that hard to add Cuttlefish to your application, and that work is mostly in Erlang, which I know you love. And time spent integrating Cuttlefish is time saved in customer support. Just that example of upgrading from open source to EE, that's customer support tickets that our customer support engineers won't be working. It's things like that. Cuttlefish lets you unit test your configuration interface. You can write unit tests to say, is this conf file going to read in and parse these app configs correctly? Are we going to get the same variable set? If there is no conf file, are the defaults going to be something that I'm satisfied with? And of course, there is Erlang when you need it. We've preserved the app config, and it lives on in the form of this advanced config file that lives right next to React Conf. We don't ship with it because you shouldn't need it. But if you do need it, if you're a developer working on the product and you want to turn some knobs that aren't exposed to customers, or you're a support engineer and you want to work and you're working some production emergency or what have you, you want to be able to tune things that we don't necessarily advertise, and that's where the advanced config comes in. And it looks pretty much like an app config, and it just overlays certain sections that you provide. So if it's empty, it just does nothing. Phased error handling. I love this one. How many times you run something, finds one error, and the whole thing bombs, and you get one error message. You fix that error, and you run it again, and you get another error message, wash, rinse, repeat, and basically, 2 hours later, you don't know how far you're actually in because there are still more error messages to go. Well, what I've done here is I've created 5 errors in a config file. We have this log console, and it can be off file console or both, but I chose that it should be Penguin because I love penguins, and we should log the penguin. I also don't think you should be rude when you're logging, so I set the level to polite. I think that kilobytes are way too big for message size, so I created like a decabyte, and we're going to use that. And, the ring size, 42 seems good. And, I don't know, just some port you should bind to. I don't care which one. Well, when I run that, I get a whole bunch of errors, all in the data type transformation phase. Now you'll notice here it says, you can't, port can't be a word port. Decabytes aren't a thing. Polite's not a valid enum value. Here they are. But you notice there's no log message about 42. 42 is in the validation phase, and it comes later. And there were certain concessions I had to make there. But you get a pretty big dump of here's the problems, and you should fix all of these before moving on. And I think there's only like 4 phases. So you're only going to do this loop 4 times instead of potentially forever. So that's nice. It is nice. And, I'm charming you about configuration. And, you've bid. I've sold you. We've done it. And you're in. You want to do it. Well, here's how. The schema. You got to define this stuff somewhere. You got to make the rules. There are rules for these configurations. Otherwise, it'd be no different than an app config. And here's how the application kind of works. What we've got is this E script down in the bottom left corner here. And he does all the work. He does all the processing, all the converting, all the generating and stuff. And what he really does is 2 things. The first thing he does is he packages a default comp file with the rebar plugin, if you're into that kind of thing. But what it does is it takes the schema, reads all the defaults, and spits out a packaged configuration file. This is the React conf that ships with React 2.0. It is generated from nothing but the schema. The other thing it does is it reads in a user's conf file at start time. It reads in the schema, and it converts that into an app config and VM arms that we're going to use to start your application. So fun facts about schemas, they're written in Erlang. Each schema element is a tuple, and the first element is that in each tuple is the type of schema element it is. Well, what even are types of schema elements? Well, there are 3. There are mappings, translations, and validators, and we're going to talk about them all. So what's a mapping? Well, it's easy, it's fun, and they're the most options, so we're just going to dig into it first. It's a 4 tuple. The first element is mapping, like I said. The second is the name of the mapping. This is going to be the left-hand side of the key value in the conf file. The third element here is where it ends up in the app config. This first guy here is the Erlang app. The second guy, it's the propolis to propolis. So these are just a dot-separated list of keys for that. And then the propolis down there, number 4, is a bunch of other options, and we'll get into those in a bit. I'm going to take this off. It's hot up here. All right, so here's the most simple mapping you can get. It's the one we just looked at, and what it does is it takes the line my.setting equals foo, and it turns it into this propolis to propolis. Erlang app setting the string foo. All right, that's not crazy. So strings, really? Yep, wouldn't be a talk about Erlang syntax and how it puts people off without talking about strings. But really, what we are here for is to say that anything that can be in a file can be a string. So if we say things are strings by default, then we're playing it safe and saying, we're not going to get any parse errors or anything like that. A string is a string is a string. But if you need more, we can use these data types. And we got lots of them. We got strings and integers and atoms and IPs and directories and files and flags and IPs and enums and data durations and byte sizes and extended data types. And why didn't you see that? Oh, you do. So let's say I don't like that string. Let's say I want this thing to be an atom because my app config wants an atom. Well, all I do is add data type atom here. And then we look at that conversion again. And now everything's the same about it, only foo is an atom. It's not a string anymore. We do the conversion for you for free. So there are more interesting ones. You know, enum becomes an atom, and when that atom is parsed, if the atom's not valid, this was that penguin example we did before, you know, if it's not one of these explicit atoms, then it's not going to work. Flag is cool too. It's for Booleans, basically. If you use flag, then the atom or string on equals true and off equals false. The second syntax for flag is you can actually specify the things you want to equal true and false there. So it gives you a little bit more flexibility. Duration, this is my favorite. So you call something a duration and you give it a unit. That is the base unit it wants to convert this thing to. So the value is a string, and it's got these units in there, like 1h 30m. It's an hour and 30 minutes. And it uses that unit variable up there to figure out what it's converting that to. So if you want to do 1h 30m in minutes, you're going to get 90. If you want to do it in milliseconds, you're going to get 5.4 million. Byte size is kind of the same. Works for megabytes, kilobytes, and gigabytes, and it does 1024, you know, power of 2 math for you, so you don't have to because you're a human and you know that you want 12 megabytes. So just type it in. We'll deal with it. Then extended data types are good too, right? We've got a list of data types, and it can be any one of them. Or specific instances of them, like this guy down here, where it's saying it could be either be a duration in milliseconds, or it can be the atom never. So let's look at bitcask expiry, because that's why we designed that feature, actually. It can be of two types of things. It can be the atom off, or a duration in seconds. And you see how in Erlang, the field name is actually called expiry secs. We're making it clear this is seconds, but you know that's not for people. You know, that's for programmers. And what we do here too with the times is we're able to say, because this is duration s, we can actually use a smaller unit like milliseconds, and it's going to round up to the smallest number in seconds. So if you say 1 millisecond, it's going to be a second. Second is the smallest thing you do with bitcask expiry. That's just what it is, but we do that for you. And it could also be the atom off, and the default is off. So expiry is off by default. So speaking of default, default's another property for a mapping. And it's the default for the configuration key. If you don't provide it, it's going to be this. It's included for the most part in the packaged conf file, which is the thing you're going to ship with. Yeah, if you don't include it in the user's conf file, this is going to be used. And almost everything should have a default. What shouldn't have a default? Okay, guys, if you've done anything with prop lists, you're going to groan when you see this next slide. But anybody seen this before? So I have a prop list with X in it, and X is the atom undefined. I am literally, explicitly saying this is undefined. But if I ask prop list if it's defined, it says, yeah, it is defined, because you put it there, you defined something. It just happens to be undefined. Well, sometimes something not being there and something being undefined actually have specific meanings that are different from each other from a configuration point of view. And if that's the case, then your Cuttlefish mapping should not have a default. You can also add commented values. It's pretty much like default, only when you generate your conf file at package time for shipping, this value is going to appear in it as a comment. It's like when you want to include an SSL configuration, but you don't want to ship with SSL on by default. You can say, this is how you do it. You know, just uncomment these lines to enable SSL. So that's what commented is for. Hidden is the same kind of thing, only it's basically saying this is an advanced knob for your configuration, and you don't want it to be in your default packaged conf. You want users to read the documentation on your website, figure out that they need this, go and turn it on, but you don't want it to say, hey guys, just turn this knob if you're feeling lucky. You can document your stuff here. That React config describe stuff, it all lives in the schema as well. It uses @doc multi-line comments that Erlang loves. Gets included in the default conf. It gets included in the command line tool for React conf describe. And yeah, that's it. We've also got C, because I wrote a bunch of documentation and realized I was going to have to cut and paste it to other settings because the documentation for two settings was exactly the same because they both referred to each other. So I just added C instead. So, and what that does is it pulls in the documentation for the other when you want to display it. From the console tool, but it also just puts a reference, like a pointer to this documentation in the actual generated config file. And yeah, if it has its own doc, if there's a doc and a C, it shows the doc, and then it says, see the other one for more details. Doesn't double doc you. So that's kind of it for mappings. You know, they're kind of basic, and they're just all one-to-one things. So what happens when it's more complicated? When you need to turn these values still even further in something that's not just a data type conversion, or when you have multiple settings that converge into one actual app setting. Well, here we are. Translation is a 3-tuple. It's the Atom translation. The second thing is the destination. This is where it ends up in the app config, the prop list of prop lists. And the third one is a function that takes in the entire config. And this function is a terrible one that always outputs the same thing, so don't do this. Do this instead. It's harder to read, so I put up the real example after we did the trivial one. We got this mapping for anti-entropy. It's an enum, and there's 3 choices. However, those 3 choices are not the values that end up in our app config because we're Erlang programmers, so we make the actual configuration values terrible. They're on and, let's see, these guys. They're on an empty list, on and list with the Atom debug, and off an empty list. These 3 tuples are the things that we configure, the values that are acceptable for anti-entropy. Well, we want it to be active, passive, and active debug. So when that comes in here, we use Cuttlefish conf get to read the setting, then just do a case statement to say, okay, convert these to whatever we're expecting in the app config. And in the end, it just looks like this, right? Anti-entropy active, runs through the mapping, runs through the translation, and what we get is React KV, anti-entropy on, and square braces, empty list. So here's another kind. We have 2 settings here, anti-entropy tree build limit number and anti-entropy tree limit build limit per time span. And if you see the third element in these tuples, they both map to the same place in the app config, React KV anti-entropy build limit. So what we do here is we write a translation for those, and what we really want is a tuple of these 2 values. And so that's what we create with this function down here, a tuple of these 2 values. And of course, the second value is actually a timestamp. So what we wind up doing is we put a default in of 1 hour, but of course, when we actually run the whole thing through, we get this tuple of 1 and 3.6 million milliseconds. So we talked about bitcast expiry before, and of course, the way bitcast expiry is actually written, what it does is it looks for the integer -1 to determine whether or not it's on or off. So, Erlang wants -1. I'm a human and want to say, turn this thing off. So we just wrote this simple translation that says, okay, well, if this thing is off in the config, then map it to -1, because that's what we want in the app config. Otherwise, if it's an integer, great, use that integer. That's what we want. If it's neither of those things, throw this Cuttlefish invalid error, and then this thing is going to bubble this bad value for bitcast expiry all the way up to the top, and your React's not going to start, and it's going to say bad value for bitcast expiry and explain to you why, because we want to explain to you why. You can include IO formats in here to say what the bad value was. Wouldn't fit on a slide, so I didn't do it. So here's how the translation works, right? If it's set to off, then just -1 winds up in the app config. And if it's set to an actual duration, then you're going to get the actual integer. It gets more complicated, of course. We've got this idea of a name. And what a name does is we like to find lists and maps of things and say, like, oh, this $sign name can be anything. So listener.http.blank, you can have as many of them as you want in React. So how do we handle that? Well, what we do is we filter, they take the conf and we filter by this prefix, listener HTTP, and then we do a list comprehension on these values, get all the IPs back, and we create this list of IPs. React actually just wants a list of IPs. It doesn't want cute names for them. We gave them cute names because we're humans and we like to name things, and it makes things easier to reference when we're talking about them. But this thing is going to take those 2 IP addresses, and it's going to map them to that. So how would a default even work here? Well, we don't want listener.http.$name to be in our packaged config file. So what we did was we created this thing called include default with a substitution. And what we're going to do is be able to say, as part of the mapping, say, oh, this thing has a default and it has a $sign variable substitution. We'll just put this in there instead. And so what we do is we throw up include default internal up there. The translation doesn't change at all. Everything still happens in the React conf the same way. And what we end up with is this in the package time conf, this http.internal. But we have this documentation that says you can put anything in there. That was for a list. We do it with maps too, right? React control auth users. We have $sign username, so whatever username, this is going to be their password. And then we do the same thing here. We do some cool pattern matching here on the actual key for the user list to get the username, because we know it's, as part of the parsing of the mapping and the conf file, we separate on the dot for string tokens. So we can do pattern matching and say, okay, the 4th element in this key is going to be the username. And so we create this list. And if the list is the empty list, we throw Cuttlefish unset. And this is to take advantage of that difference between undefined and unset. So we just use that. But what we're going to end up here is got 2 users, Joe and Mickey, and here are our passwords. And this maps to this list of username password combinations. But, Mickey's my wife, and she says, I don't need access to React control. I don't even know what you're talking about. That's why I'm not here right now. So we comment out one line. We don't have to worry about the comma between the user lists. And the thing that gets generated is going to not have the username. It's, it's going to create the list. It's going to take care of the list structure for you. It's just going to be, one user now in the user list. And of course, we don't want any users to ship with React by default. It's a security hole. If you want to add, there's no Scott Tiger here. If you want a user here, you got to add it yourself. So we ship it with the commented value also. There are plenty of support functions for writing translations. We use like 4 of these. There are a couple more fun ones with variable. Variable is the most fun because it's the most complicated. So now there are validators, and these guys are real easy, so just bear with me here. 4 tuple. First one's validator because it's a validator, and we need to know that. The second one is the name of the validator. Third one is the error message when it fails. And then there's a function. It's true or false. Takes in the value you're validating and says whether or not it's valid. If it's true, everything's fine. If it's false, this error message in element 3 bubbles all the way up to the top and tells you can't start React because reasons. So here's a new mapping element that I forgot to add a little tagline on the bottom, but this is also in mapping. It's just a list of validators for this mapping. And that later is actually now because I moved the slide around. So here it is. Ring size. It's easy. Default is 64. It's an integer. It's got 3 validators. Ring size power of 2, ring size max, ring size min. Ring size max, take our 42 example before. Ring size max, well, it's less than or equal to 1024, so that passes. Ring size min, it's greater than or equal to 8, so that passes. Ring size complicated bitwise and for determining power of 2, well, that fails. This thing, 42, does not pass that, so we get that now not a power of 2 message that we saw before. So great, you now know everything you need to know about writing a schema. If you forgot like all of it, that's fine. It's all in the Cuttlefish wiki that you can see on GitHub. But what even do you do with these schemas? Well, the first thing you got to do is drop it like it's priv. Priv directory is a great place for these things to live. This way we can reference them from other projects. Every project that React includes its own schema for the settings for that particular project, and they're all aggregated at the top level. Top level projects can also have schemas that override these things. You can twist your mustache. We do mustache substitutions with rebar. So you can have a mapping like this that says, at package time, we're going to substitute this platform data directory in here. And by the time we generate this thing, we're going to have platform data directory be, like /var/data, whatever for some people, and, ./data for Mac users or whatever. So it's good. It's a good package time way to do things. You can write a unit test for your schema. How do you do that? Well, Cuttlefish unit is it's a good module, A+++. I would write it again. What it does here is it reads in a schema file, and then this is testing the default. So this second element in the function here is actually just what the effective config coming into the application would have been. In this case, it's nothing. It's a 0 conf. Nobody's configured anything. And then context I'll get to in a little bit, but it's just the mustache substitutions. So what I do here, I'm just checking to see, okay, if you don't do anything to your conf file, what's the React core ring creation size going to be? Well, it's going to be 64, so this assertion passes. And what about SSL? I told you we like to ship that commented. Well, there's going to be no configuration, so we assert that it's not configured. And so here's the context. It's just a list. It's just a prop list of substitutions that Mustache should do, and we did them for you in the unit test framework, so you don't have to worry about that. Unfortunately, you still need to be running these unit tests via rebar for this particular bit to work. So you want to test custom overrides. What happens if you set a conf to these values? Will they all get overridden correctly in the app config? Well, you see here, these are the way that Cuttlefish actually understands these keys. These are the dot separated tokens that are how we do pattern matching and stuff from before. But what we've done is we've set ring size to 8, and we set the SSL cert file to this. And we just run the same function again, only this time instead of an empty list, we've got conf in there in the second argument. And then we can test to make sure all these things got overwritten correctly. And like in the React core module that I lifted this from, it's actually like 20 lines of conf and a whole bunch of assertions to make sure that everything gets overwritten correctly. Yeah. So how about a nice cup of rel tool? Well, these things got to get into your app somehow. So what we do here up here first is we copy the Cuttlefish E script into your Erlang runtime. And what that's going to do is get you a the Cuttlefish executable for us to work with. I mean, without it, you can't do anything. It runs in a separate VM before your app starts. So it's able to ask VM the questions about itself before setting the app config too, which is actually really cool. Then down here, we've got a bunch of templates that we're running through Mustache, making sure they all get to the right place where React's going to look for them when it starts. If you notice, there are some numbers in the destinations too. That's because these things are read in order, and you can override things. So the lower the number, the higher priority. In the React schema, we can actually override a setting that came in from the Erlang VM schema and say, okay, you know what? The Erlang VM schema says our cookie should be cookie, but we want our default cookie to be React, so we can override that. And if you don't want to override everything, just one thing like the default, but you don't want to change any documentation or anything, we've added this property to the mappings that's just called merge. And what that does is says, you know what, yeah, we only wanted to change a little bit. We don't want to completely blow away the old one. They had good things about it, but we just didn't like the default, so we're going to change it. So what do? Well, if your release has a rebar config, you add these guys to it. Just says, use the Cuttlefish rebar plugin. You can name your conf file. So when you use Cuttlefish, you don't have to have a React conf. You can have whatever your app name is you want conf, which is great because only us want a React conf. And if you use node package, it's even easier because you can just turn Cuttlefish on and specify that same conf file name in here, and it knows what to look for. So what does node package give you? It gives you a present. It gives you all of these flags already set to the Cuttlefish eScript command line arguments. Here's what they actually do. So E is for the Etsy directory. It's where you wind up writing these things. D, destdir, that's where the generated app configs actually go. S is schemadir, where you look for these schema files. And C is the conf file you're loading in this case React conf, wherever it actually lives. One thing I didn't show you on that last slide, because it's not included by default with node package, is this -L log level. And if you have a problem with your config at all, you just do -L debug, and you do that in the React config generate, and you're going to actually see all of the output, not just the error messages, in case you're trying to do that. So where does it all end up? Well, generated config files end up here in your data directory in the generated configs folder. They have a timestamp in them that is by descending order, so they actually sort nice in a directory, which seems nice to me. And it gives you an audit of the configs you've started with. The bin directory is where the Cuttlefish eScript winds up going. There's other stuff in there too, but I took it out because it made the slide too big. The React conf file ends up in your Etsy directory, and the lib file is chock full of schemas in a priority order. And what does that give you? Well, it generates this. It's not pretty, but it gets the job done. It's the kind of thing that Erlang applications love and humans don't. So you don't actually see it if you don't want to. And so here's another thing. Here's generated VM args. And that's weird. Where did that all come from? We've been talking about app configs all day. Well, there's a special prop list in my in Cuttlefish here called VM args. If you use it in the third element there, what it's going to do is wind up generating VM args. And you can see all kinds of examples for this in the Erlang VM schema that is in the, where is it? It's in Cuttlefish. Cuttlefish gives you an Erlang VM schema for free because I figured any Erlang app would need an Erlang VM schema. If what you want is missing from it, pull request, send it to me. Just ask me, open an issue even. I will add it because I want to make this complete for anybody who wants to package an Erlang app, just have these things available to them. So that's a special prop list that Cuttlefish knows what to do with. And then what happens? Well, also, as an added bonus here, we generate these command line arguments that you need for an Erlang VM. So the output of Cuttlefish, everything that we've seen so far, especially in the generation parts of this thing, all outputs to standard error. Why? So the only thing that comes out on standard out is this one line about config and args file. So you can just take the output of that command and slap it on the end of your URL command to start up your VM. But you're looking at this thing and going, why did I put the VM args file in there twice? I've got args file and I got VM args and it's the same file. Well, the answer is because sometimes you want to ask the Erlang VM, what did you start with? What was the args file that you started with? What was the config you started with? Well, when you ask it what config you started with, it's like, cool, man, this was the config I started with. And if you ask it what args file it starts with, it went, hey, man, I threw that information away because I only needed it the one time. However, you can pass in anything else you want, and it's going to save that. So this guy here, VM args, is just there for you to query your running VM and ask, hey, what VM args file did I start with? But we don't actually need that. We just need that, for runtime analysis. So that's it. You can find all this code at github.com/basho/cuttlefish. There's a wiki there with all sorts of information that I didn't get to if you want to read it. And I'm here, to answer any questions you might have. So, yeah, thank you. Oh, great. Yeah, so there was a slide up there about the @doc multi-line comments. So mappings themselves have comments. And those comments, anything you annotate with a doc, will make it into the generated config file and also be the output for the describe command.
So if I wanted to go back and figure out what particular part of the input actually contributed to the output, the line and file number and things like that would be obviously painful for me to manually edit in there.
Okay, yeah, that's actually a great point. So one thing that I did while writing the schemas, and it didn't even occur to me to bring this up here, but it's great, is because of the way we're parsing in the schema files, as a developer for applications working with these schemas, when you have a mistake, I am gaining enough information from the processor to say, you know what, you have a problem with this mapping, and it is in this file at this line. So there is actually debug output. Most of what I was talking about here in the talk assumes that work is already done and you are working with a deployment and what happens in a working system. But as you are developing a schema, there is tons of output in the Rebar plugin that tells you exactly what's happening there. Did that answer your question?
Well, just, since if you had to look at the runtime file and you have to figure out, wait a minute, something's wrong, how do I know the file I'm actually editing is not the file I'm looking at?
All right, so the file that you're editing, yeah, let's see. So when you want to do runtime debugging, the first thing you want to do is use that React config effective tool, which is going to tell you this is exactly what we built and what all the defaults actually are set to. Any changes you want to make are just in your React conf file. If you're debugging any deeper than that, it's because you have an understanding of the app config. And so as a developer of your application, that could get trickier, but that's why in the describe command we sort of included that little bit of information, like this is the thing in the app config that this actually has an effect on. Neil? Nope, I'll do you first.
Just a little basic thing, I guess. In that example with the penguin and the Datatypes and so on, the error messages that came out in the opposite order as the items in the config file. Just wondering whether that was consciously done so that, after a lot of scrolling, you would see, the last thing you'd see would be the first error, or whether, there's some machination in the program that is spitting it out that way.
Yeah.
It really should be,
So the question is, did I show the errors in the wrong or in a reverse order on purpose? And the answer is no. There's probably a fold R where I should have fold L'd. It's basically, there was a lot of that in this because unfortunately there's a lot of iterating through each phase. You sort of have to start again and iterate through. And there were a lot of, I won't say a lot because how much performance do you really need with parsing a config file? But there were a lot of places where I said, you know what, I'm going to do this again and add another order of magnitude because I'm going through this whole schema again. But what I'm going to do here is be able to give you better error messages for it. That thing with the Levenstein distance where it gives you suggestions about what schema element you were trying to set, that thing has to, I think that's like order n to squared or something like that. But if you do that, it's a rare enough occurrence where you want to do that extra processing work and help the user out. I think you had one too?
Do you have any patterns or best practices for setting a different config per environment? So like production versus staging versus?
Yeah, so what we did, we used that with Mustache as well. And what happened was in our React top level schema, there's actually a block of code that doesn't get executed unless you're doing a developer release, which is that thing where we run 6 nodes on one machine so that we can test things, but that's not something that production users want. So in that, we want to set the amount of memory that LevelDB uses to be a much smaller number, because otherwise you grind your laptop to a halt and you can't use it because you're running 6 React nodes at once, and they all want 8 gigabytes of RAM. So we have this block called devrel in Mustache, and when Mustache sees that set, it adds this extra setting, which creates an override schema element for LevelDB memory size, and changes the default to a smaller number that's manageable.
What happens when a property is defined that isn't used or honored in the schema?
I'm not sure. I'm sorry, I'm not sure what you mean.
Let's say your customer gets in there and he puts another line in the config file for something he thinks he can set.
Okay, so yeah, that's that same example. I mean, it works the same as the fat finger example with anti-entropy, right? I put something in there that shouldn't be there. It happens to be close to something that should be there, so the thing tells me. This thing is still going to try and guess what he meant, and he might have it might just guess wrong because he meant something that doesn't exist at all. But that's the same kind of thing that'll happen. Fred, do we have any more time? Or? Oh yeah. All right. Yeah, I'll be here. I'll stay around if I think lunch is now, but yeah.
Are we able to validate the configuration values against each other? For example, we say we have switch something on dot high, switch something on dot low, and we wish to restrict them against each other.
Okay, so
High value would be higher.
yeah, let's I haven't built that in yet because the validator is all the way the validator works is it takes in a value and does the math on that particular thing. Say like, is this thing? It doesn't say relative to each other, but it probably could be done in a translation, right? Because we have. Oh, I'm sorry.
That's not properly good. That translation must translate.
Well, the translation has that Cuttlefish invalid function that it can throw, and that essentially throws an error up to the processor that says, okay, we got to a point in this setting where we know we can't set it because somebody set something else to on, and this can't be set if that thing's on. So I'm going to complain, and I'm going to have a detailed message about that. So you can actually do that.
We'll still have a neat message for the end user.
Yeah, but you'll have to actually write that message in the translation because it seems like a specific thing. So you'd actually want to take the time to craft words and not have us figure it out for you. But if you have a specific example, I'm happy to take it offline and just tweet me or whatever. Awesome. I love talking about this stuff.
We're done, so let's give another hand to people.
Thank you.